A vacuum pump and balloons can demonstrate Boyle's law. A balloon is placed under a vacuum jar, and the pump lowers the air pressure. As the pressure lowers, the balloon grows. Its volume increases according to Boyle's law. When the vacuum is removed from the jar, the pressure quickly rises, returning to ambient pressure. The balloon also returns to its original size and volume. Suppose this red balloon represents the lungs of a diver. Like a diver ascending too quickly, holding his breath, the surrounding pressure on his lungs decreases significantly, while the pressure inside his lungs increases. This would cause his lungs to expand rapidly. If the pressure differential is great enough, a diver could experience lung rupture. This can occur with as little as 1 meter or 3 feet of depth change.
All right, we're in the gas law chapter, and we're going to start off with Boyle's law today. You just saw the video dealing with Boyle's law. We've done some stuff in class with Boyle's law. Now we're just naming it. So Boyle's law. All right, Boyle's law states that the volume of a given amount of gas held at a constant temperature varies inversely with the pressure. So with Boyle's law, we're just dealing with pressure and volume. Temperature remains the same, okay? So temperature is constant. We're just dealing with pressure and volume. So how do they relate? All right, they're inversely proportional. When one goes up, the other one goes down. Okay? So if you increase the pressure, the volume goes down. If you decrease the pressure, the volume goes up. All right? So our equation for Boyle's law is P1 V1 equals P2 V2. All right? What the 1s and the 2 means is here's what you're starting with. Your pressure and your volume you start with. So let's just say you had like a water bottle that was closed off. Okay? The pressure and volume you start with, then you squeeze. All right? You're going to get a new volume and a new pressure. All right? So that is Boyle's law. P1 V1 equals P2 V2. Yes, you do need to know that it's called Boyle's law. All right, I'm going to do a calculation for you here. So a sample of helium gas in a balloon is compressed from 4 liters to 2.5 liters at a constant temperature. If the pressure of the gas in the 4.0 liter volume is 210 kPa, that stands for kilopascals, what will the pressure be at 2.5 liters? Okay. So for this one, again, we have P1 V1 equals P2 V2. Write your equation down every time. Okay, let's start assigning. So the 1s and the 2s, remember the 1s are the beginning. So what are we starting with? Okay, a sample of helium gas and balloons compressed from 4.0. We must be starting at 4.0 liters. So P1 is 4.0 liters. All right. It goes to 2.5 liters. So P2, oh, I'm sorry, I'm saying P, aren't I? Volume, I mean V1 is 4.0 liters. Sorry about that. V1 is 4.0 liters. And V2, it's going to 2.5 liters. That's volume. So it's going to end up at 2.5 liters for V2. All right, at the pressure of the gas at 4.0, so at 4.0, what do they tell us the pressure is? 210 kPa. So, if I have room here, 210 kPa. Sorry about that, it kind of got small there because I messed up. Anyways, so 4.0 at 210 kPa, those go together. So that's pressure 1 and volume 1. What will the pressure be at 2.5 liters? That means we must be solving for P2. All right, so we get our calculator here. 210 times 4.0 liters. This is going to end up as 840 with 2 sig figs. kPa times liters is equal to P2 times 2.5 liters. We want to get P2 by itself. So let's divide by the 2.5 liters on both sides. Your liters are going to cancel out. P2 is equal to, so 840 divided by 2.5 with 2 sig figs, you get 340. Our only unit is kPa that's left, which makes sense because we're dealing with pressure, and kPa, kilopascals, is a measurement of pressure. Okay, so that's how you calculate Boyle's law. P1V1 equals P2V2.